students, good morning. Today we discuss about the application of derivatives part 2. In the part 1 we already discussed the rate of change of quantity, and in the second part we discussed the increasing and decreasing function. What is increasing? I just use because in increasing and decreasing function we also discuss a lot of or number of types of curves. So when it's a increasing means related with the curves, first of all we discuss about the straight line. We know that the equation of straight line y is equal to mx plus c, where m is slope and tan theta. I am here consider the two equations of curves. Y is equal to x plus 3. When y is equal to x plus 3 and when I compare with this y is equal to mx plus c and y is equal to x plus 3, or you take any constant term that is a 5 also, there is no problem because that's the value of c. So this is x is 1 and this is m, so m is equal to 1. M is equal to 1 means tan theta is equal to 1, and when tan theta is equal to 1 means tan pi by 4. So theta is equal to pi by 4. So approximately we can say the graph of this straight line is just like this. This is the case of increasing. The value is increasing. Now another case I am taken minus x plus 5. This the coefficient of x is minus and here the coefficient of m. So m is equal to minus 1. So tan theta is equal to minus 1 means tan 3 pi by 4. And when this 3 pi by 4, we draw the graph is just we can say like this. But for the increasing and decreasing function, we have to also discuss some different types of graph, and the best graph of this one is a parabola or parabolic path. This is a parabolic curve and whose equation we can say y is equal to x square. Equation of curve is equal to y is equal to x square. Here this graph is divided into parts. One part is the right hand side of your 0, means all the positive values, and here the left hand side all the negative values. So the right hand side portion we can say it's a increase in the case of increasing function, and the left hand side it is case of decreasing function. This increasing and decreasing function briefly we can explain like this also, and now after that we according to our definition we consider the strictly increasing and increasing function. Here we take the examples of increasing function and strictly increasing function. This is the graph of increasing function, where this x1 and x2 are the two open intervals, and in between these open intervals this type of curve is present. Here x1 value is definitely less than x2 value. We can say that is x1 and this is equal to, if you wish you can expand it, and it is equal to x2. And this x1 is less than x2 of course. So fx1 is less than or equal to fx2 is increasing function. Here I just also explain about this tangent just for a, this is suppose this is my curve, and in this curve at each and every point we show the direction by the help of the tangent, and this can be represented like this at every point. Here this tangent is just parallel to the x-axis. Here this direction is just going like this. And here every point we show the direction of this tangent. And this is also this type of tangent, and this is increasing function. In the second curve, it's very difficult to find out what is the tangent. And it is a strictly increasing function where x1 and x2 belongs to this ion interval, and this is the sign that fx1 is less than fx2, means it's never that the functions are equal, and this is the most important sign for this strictly increasing and this increasing function. This is less than or equal to, and this is only less than. Now, this is the decreasing function, strictly decreasing function. Of course, all these intervals are same x1 and x2, but here this fx1 is greater and equal to fx2. In the decreasing, it is greater and equal to, and in increasing, it is less than and equal to. And similarly, the strictly decreasing function, this is fx1 is greater than fx2, and therefore we can say that this is the sign, again the most important. This one is and this one, they are greater and equal to and greater than this fx1 and fx2. So this is the strictly decreasing functions. Now this is the one, maybe some conditions are also arise in the case, that's a normal condition, that it's neither increasing nor decreasing. Our majority sine and cosine graphs are just neither increasing nor decreasing from 0 to 2 pi, as we already discussed in trigonometry, and as also as the inverse trigonometry also in different aspects. So this is the case of strictly increasing and strictly decreasing, where this is your O, this is your X, this is your X dash, this is your Y, and this is your Y dash, and this is actually neither increasing nor decreasing function. The first example that show that the function fx2x minus 3 is strictly increasing function. Suppose x1 and x2 are belongs to intervals. Intervals, that's your open interval. And this strictly increasing condition is x1 is less than x2. Here I am multiplying both sides by 2x1, and actually this is 2x2. After that, I want this function fx is equal to 2x minus 3. So in the form of this 2x minus 3, I just subtracting from 3 and both sides, and that is 2x2 minus 3. If fx is equal to 2x minus 3, then this fx1 is less than fx2, and this is the condition of strictly increasing. Therefore, given function is strictly increasing function. The given function is strictly increasing function. This is the completion of this question. In the second example, prove that the function given by fx is equal to cos of x is strictly decreasing 0 to pi and strictly increasing pi to 2 pi. And third case, neither increasing nor decreasing. Here in the increasing and decreasing function, we have to first of all differentiate the function. Fx is equal to cos of x, so f dash x is equal to d by dx. Cos of x is equal to minus sine x. This is the most important factor, that sine x function is negative. Here we just go through our previous knowledge of sine different angles from 0 to 360 degree. Here this sine angle 0 to 380 degree, it is strictly positive. In normal circumstances, it is strictly increasing function. But due to this minus sign, this 0 to pi or 0 to 180 degree, it is a decreasing function. And similarly, when this 210 to 360 degree values all are negative. So they are, in normal circumstances, they are the decreasing functions. But due to this minus sign, it becomes the increasing function, strictly increasing function. And the third case, neither increasing nor decreasing, the whole from 0 to 360 degree, all the values are neither increasing nor decreasing. Here the function f dash x sine minus sine x is strictly increasing because due to minus sign, and strictly decreasing when 180 to 360 degree because all the values are negative, and this is also f dash x is also minus, so it becomes positive. And from 0 to 360 degree is neither increasing nor decreasing, so we can say that 0 to 2 pi it is neither increasing